Hello and welcome to the AVLI class on ArrayList. Before we start with the code, and you can certainly look through it, I want to explain what an array list is. Basically, we have an array list, which is a class within Java that you can see is imported on line 1, part of the Java util library. And it handles and stores information like an array. There are a couple of differences, and one, when you declare an array list, use the new keyword to create the object, and there's no size given. So an array list can add and subtract elements as needed, unlike an array, which has a finite size on declaration. The other difference is an array list can only contain objects. So here we have an array list set up to contain a student object, which we'll explain later, but it can't hold any of the primitive data types like int, double, boolean, etc. So it only contains objects. And because it's a class, it has a number of methods. And so let me show you some of the methods that you need to know for the AP exam. So I'm looking at the quick reference, which is given to you at the exam time, and that you should become familiar with using as you work through your problems. And there you have the ArrayList class, and there's a number of methods within it. Unlike the array, which has a length, in order to get the size of an array list, which is the number of elements in the array list, use a method called size. And in order to add an object at the end, you would use a method called add. In order to add at a particular index, you would provide the index and the object, and it would add at that particular index and shift the element at that index and all the remaining elements to the end of the list outward. So it doesn't overwrite the value at that index, it just shifts all the ones remaining towards the end of the array list. There's a get method, and you can see it just returns the element at the particular index. And there's a set method, which will replace the value at that index. So you give it an index and you give it the object, and the value at that index is overwritten. And then finally, remove. And remove is given an index, and it removes the element at that index, and furthermore, all the elements after it shift down, so there's no gap in the list. Basically, ArrayList will manage its addition and removal of items naturally, leaving no gaps. If you did that with an array, inserting or deleting an element, you would have to, if you were interested in not having a gap, manually move elements. So the ArrayList class takes that responsibility away from you and manages it itself. So do want to tell you that an array list always appears on the exam. Types of questions, you will be marveling at it. Most people like array lists because it's easier to use than an array, and we'll get into it in a little bit. So familiarize yourself with these methods. There are others. You may stumble across them, but these are the ones that are testable. So let's look at what I've done. So I've created a class roster. Everybody is familiar with a class roster. This one has one. And its basic structure is, and I I forgot to put the word private here. And so its basic structure is that it is an array list. So I create two constructors, one which is just creating the array list called the default constructor. You can see that it's of the type student. And then I have a class roster where it takes in a student and therefore creates the array list and then adds a student to it. So I did that for convenience. All right. So the class roster has a length method that returns roster.size. So I'm calling an array list method size. The class roster has an add method which takes in a student and calls the ArrayList add method. The class roster has a add at an index that will add the student at that particular index, and if there is a value there or any following students, it will shift them out towards the end of the list. Remove takes an index and just simply removes the value. And I want to say the ArrayList remove method returns the object that's being removed in case you want to use it. Okay, so that's something. Most times you don't use it, but like if you were interested in removing it, then you could do that. We have a get method that just simply is given an index and returns the value at that index. And we also have a set method which takes an index and a student and sets the value at that index to the new student. Whatever object, or in this case student, at that index will be overwritten. Okay, so it will be replaced. And then finally I have a toString method for convenience, and I take a string and set it equal to nothing, and as long as the size is greater than or equal to 0, I use a for each loop to construct a string and return it. And if it isn't containing any elements, I return roster as empty. So that's a class roster based on an array list. And so what I create is an array list as its fundamental data type, class instance variable, and then I rely on the array list methods to implement similar methods in the class roster. So a quick look at student before we go on. Okay, there is a default constructor within student. I conceive of a student as with a name and an ID. So there's certainly more to student record, probably grades and parents and emails and such like that, but like I'm going to have a simplified student class with just a name and an ID. In order to construct one, you give it a name and an ID, and it does it. And it has get name, get ID, set name, set ID. A toString method, kind of useful. We've talked about that. That's to override the capital O object toString method. And then we have an equals method, which you should build in as well, always to override the capital O object class equals method. So we're comparing, in this case, name and ID to another student. Okay, so you can look at that. That was introduced last class. So let's get to the use of the class roster and the student class here in a thing called ArrayList. And it has a main method here. Just give it a little space, and I create a new class roster with a student, frankly, D. Roosevelt, and an ID. So I'm calling the student constructor and adding it to the class roster, calling that second class roster constructor, which creates an array list and puts a student at the first element, which, by the way, is numbered like an array. So the first element is at index 0. Okay, and that's important to understand. And the last element is at index size minus 1. All right, so it's the same bugaboos about like iterating through an array list with a loop, staying away from the size of the array because the last index is size minus 1. So I add at index 0 Susie Spoons, which pushes Franklin D. Roosevelt to index 1. And then I add another one, which is added to the end because an index isn't given, Roger Dodger. Okay, and then I'm going to print the list. Finally, I take the value at index 1, which is Franklin D. Remember, I put Susie at index 0, pushing Franklin D out to index 1. And I'm going to print it out. So I'm going to get the value at index 1. Then finally, I have set at index 1 Spunky McGee, and it overwrites Franklin D. So bye-bye Franklin D. Roosevelt. Spunky H. McGee is in there. That's what the set method does. It overwrites a particular value at that index with a new value. So then I added index 1, Sally Shortbread, which pushes Spunky McGee out, and I print the class. Finally, I'm going to remove, if you're keeping track of what the array list is, Susie Spoons at index 0, and all the values after Susie Spoons shift down. So what happens then? Sally Shortbread shifts down. And we'll just run this and show you. Okay. All right, the first print shows Susie Spoons at index 0 because that's where I added her. Franklin D has been pushed out to index 1. And Roger Dodger has been added at the end of the list in line 6. Then I ask for the value at the index 1, which is currently Franklin D. Roosevelt. So that's all good. My get method works, and now I'm going to obliterate Franklin D. Roosevelt and set the value at index 1 to Spunky McGee, and I've overwritten that. And then I'll add at index 1 Sally Shortbread, okay, so that Sally Shortbread will be added at index 1. And you can see that in the output down there. It's Susie Spoons, Sally Shortbread, Spunky McGee, and Roger Dodger. Finally, I print it out again, and then I remove at index 0. So I really didn't like Sally Shortbread, and so I've Susie Spoons rather. My two original characters, Franklin D and Susie Spoons, are out, and Sally Shortbread, which was in index 1, shifts down, and so on, Spunky McGee and Roger Dodger. So I think this explains maybe how a class roster works, but perhaps it's a little confusing because my class roster is based on an array list. And while it has its own methods that are similar to and sound like the array list methods, in truth, I'm calling roster.add and roster.add in this case, and roster.remove. And because roster is an array list, I'm calling the array list methods. So this is kind of a more complicated example. When I started it, I'd be like, should I do this? But like, we're fresh off the unit on creating classes. And so I think we need to step up, have multiple files in action. We want to see the interplay between the classes and how communication happens. And so I think this is a good prelude to what we need to do in the second semester. So this has been the class on ArrayList. Reach out if you have any questions. Good luck with this week's assignments.